Okay, Specialist Mathematics Paper 2, Tech Active X 2023, external. We're working our way through the short response and we're going to do question 12, which is a complex number question. Consider the number z is -3 plus 2i. Determine z cubed using binomial theorem. Leave your answer in a plus bi form. 2 marks. Now it actually specifies using binomial theorem. Cube. Now we know with binomial we're going to use our coefficients of Pascal's triangle. To start, that's going to be -3 cubed, -3 squared, -3 to the 1, and then you're going to have 2i cubed, 2i squared, 2i, and then I put in my coefficients of 1, 3, 3, 1. That's my easiest way to do binomial, is always do the first term to my power and just take it down by 1 each time, get to my end one, it's at my max power, then it goes down to. Now, we had to show binomial, 2 marks. We're tech active. So I think we get to this point and go, let me do that on my calculator. If you don't want to, this is going to be -27 plus 27 times 2i plus, that's going to be -9, isn't it, times 4, which is -36i squared plus 8i cubed. -27 plus 54i plus 36, and that'll be -8i. Oops, sorry. Leaving me with 9 plus 46i. That was doing it tech free. Pop it in your calculator. You had to show that you'd done binomially, but then if you've done this in your calculator, you only get then a mark for your answer. So you get a mark for that and you get a mark for that. This was just me being old and I do things by hand. But use your calculator. Remember your calculator, if you go options complex, is where your I is. Okay, so if you need to put it in, enter it with that. Now, I am going to use my calculator here. Convert cis into polar form. Okay, we can do this. Now, cis is R is my magnitude, theta is my arg. You can do this by, if you go complex, I want the absolute value of -3 plus 2i, r equals √13. The arg, bracket, -3 plus 2i, close my brackets, 2.55. What are we working in? We're working in radians, so we're good with that. Is my angle between my domain? This is -pi. Pi is -3.14, 3.14. 2.55 is in that range, so I'm good. So it's √13 cis 2.55. That's my answer. It's only 1 mark, so that's all you need to do. Use your result from 12b to determine z cubed using de Moivre's theorem. Leave your answer in that form. Again, watch your domain there. So if I go √13, cis 2.55 cubed, by de Moivre's theorem, that's root 13 cubed cis 2.55 times 3. Correct? Put your magnitude to the power, multiply your angle. Trusty calculator. I'm going to go shift root 13, close brackets to the, delete, close bracket, to the power of 3, 13 root 13, cis 2.55 times 3, 7.65. So that's looking like we've got it in cis form. Good on us. But checking our domain, this is negative 3.14, this is 3.14, 7.65 is outside of that. So I'm just going to go 7.65, take 2 pi. Just take away a revolution. So if I take away 2 pi, and I get 1.367. So this is 13 root 13, cis 1.367. That's my answer. It's in polar form and my theta is in the correct range. Now, D is evaluate the reasonableness of your results from 12A and 12C, noting that 2 methods to determine Z cubed should produce the same result. Okay, so we've got to use A and C to see if we get the same result. Well, let's just go from C for the moment. I've got 13 root 13 cis 1.367. So that's 13 root 13 cos 1.367 plus 13 root 13 sine 1.367 I. Let me go to my trusty calculator. 13 shift root 13 cos 1.367, I get 9.48 plus or 49, depending where you want to go. Then I've got 13 shift square root 13 sine 1.367, and I get 45.9 I. Is that close to what I got in A? In A, I got 9 plus 46 I. It's pretty close. There would obviously be, we rounded off the angle. So I'm going, yeah, that's all good, because there would be some rounding there. If you used a more exact angle, you'd get closer. Going the other way, using A, which is 9 plus 46i, if I go the absolute, 9 plus 46i, so my absolute R equals 13 root 13. My arg of 9 plus 46i, 1.377. Pretty darn close, isn't it? So 13 root 13 cis 1.377. So yep, pretty close. So we evaluate that it is reasonable. Because remember, it's not that it's exact, it's that it is reasonable. Okay? Done.